Alright, so Ariana, Boris, Cecile, and Diego are students in the service club. 3 of the 4 students will be chosen to attend a conference. Which choice represents the sample space for this event, and they're calling it S? Well, the sample space is just a list of all the possible groupings. So they're doing 3 of the 4 students. So the 4 students, of course, are going to be referred to as A, B, C, D. Alright, so if we're going to pick 3 of those, let's start with, what if, let's start with all of the ones that have A in it. Okay, so if A is in it, then it could be alright, so I have one too many here. So there are only 3 groupings that would have A in it. A, B, C, A, B, D, and A, C, D. Alright, there's no other grouping other than these that has A in it. Now notice, and this is the key to why you got this problem wrong, the order doesn't matter. If I rewrite this first one as B, and then A, and then C, these are the same. Alright, because we're just talking about groups of students that are being taken to a conference. Alright, the order has nothing to do with it. Alright, so group ABC and group BAC are the same 3 kids. So you would not list these separately. So looking at the choice you picked, you have ABC right here, but then you have BCA as a separate choice. Right, but these are the same, so that's why this is wrong, because you wouldn't list both of these. So that's where you went wrong. So so the key is, let's see how many more there are out there. All right, so I've added in B, C, D. Now we have all 3 ways that involve B. Alright, so we have all the A's, we have all the B's. We also have all the C's. 1, 2, 3. So we have all 3 groupings that involve C. And we also have all the D's. 1, 2, 3. So this is it. Alright, there are no more groups of 3 that you can make out of these. There are only 4 of them. And here they are. So that's why this is the answer, because it matches. ABC, that's this one. ABD, that's this one. ACD, that's this one. And BCD, that's this one. All right, those are all the options. That's why that was the top one was the answer. Alright, so this question is asking which 2 events are independent. Here's the test. Here's how you show if 2 events are independent. So if event A and event B are independent, then the probability of event A, given that condition B is true, should equal the probability of event A without any conditions. Alright, if this happens, then the 2 events are independent. So what we need to do is take each pair of these and test to see if the probability of one given the other is the same as the probability of one by itself. That would mean that the second one doesn't really matter, and that's what it means to be independent. So let's check that. All right, let's start with A and B. Let's see if they're independent. All right, so we need to figure out the probability of A given B. So B is the burrito is a carne asada burrito. Okay, so if we're going to be given this, we're given the burrito. Okay, that means we're given that we're definitely in this column right here. This is what we're given. That means that the rest of it doesn't matter. Okay, so we can forget about these numbers over here. We can forget about these numbers over here. This is the universe. It's what we're given. Okay, so in this smaller universe, now what is the probability of A? Well, A is the burrito is a chicken burrito. Well, it can't be both. If we're given that it's a carne asada burrito, it cannot be a chicken burrito. So the probability of A given B, that's 0. Okay. Now, if we're not told, if we're not given B, we just want to know what's the probability of A. What's the probability that it's a chicken burrito? Well, then we can just look at the number of chicken burritos and look at the total number. So that probability is 83 out of a total of 240, which is clearly not 0. Okay, so these events A and B are not independent. All right, they're not equal to each other. All right, so let's keep going. Okay, so
Good afternoon, the econ course, almost passed.
All right, now let's test B and C. If event B and C are independent, then the probability of B given C should equal the probability of B by itself. All right, this time let's do this one first. All right, let's calculate the probability of B, the probability that the burrito is carne asada. All right, so probability, we do target over total. So our target is event B, carne asada. So there's 80 of those out of a total of 240 burritos. Okay, 80 out of 240. All right, that's 1/3. All right, now let's figure out the probability of B given C. All right, well, if we are given C, that means we are given, hold on, we're given the customer requested black beans. All right, so this is what we're given, black beans. Okay, that means we can forget about the rest of all of these. Okay, the universe is now just black beans. Okay, so in this smaller universe where we're given C, now what's the probability of B? All right, B is carne asada. Okay, so that's right here. So we have 5 carne asada. All right, we're doing target over total. So 5 carne asada out of a total of 45. Okay, let's see what that reduces down to. All right, that's 1/9. Those are not equal. So that means that event B and C are not independent. Okay, so we tried B and C. They are not independent. All right, let's try C and D. Okay, so the probability of C given D, that should equal the probability of C by itself if C and D are independent. Alright, so let's calculate the probability of C. Target over total. C is black beans. Okay, so let's see, black beans, we got 45 of those out of a total of 240. Alright, that's 3/16. Okay. Alright, now let's calculate the probability of C given D. Alright, if we are given D, that means we're given pinto beans. Alright, so we're given pinto beans. Okay. That means we can forget about everything else. Okay, we can forget about everything else, just pinto beans. Now, in this pinto bean universe, what's the probability of C? Well, that's 0. Alright, because C is black beans. We're not doing black beans and pinto beans. It's one or the other. So obviously 0 does not equal 3/16, so it cannot be C and D. Okay, what have we not tried yet? Okay, so really, at a glance, the only possibilities are we have to put burritos with beans. So there's no point in doing burritos and beans and beans. Alright, so let's mix and match burritos and beans. So let's see. So we did B and C, so that was a good try. Okay, alright, how about A and C? Let's try that. Alright, what's the probability of A given C? If they're independent, that should equal the probability of A by itself. Okay, probability of A by itself. Chicken burrito. Okay, there's 83 out of a total of 240. Okay, that doesn't reduce. Alright, now, how about the probability of A given C? Alright, so if we're given C, that means we're given black beans. So we're given this. Alright, that means the rest of these did not happen. Okay, now let's calculate the probability of A under these circumstances. So A is chicken burrito. Okay, so chicken burrito out of a total, so that's 37 out of 45. Alright, that does not equal 83 out of 240. So A and C are not independent. Okay. What about A and D? All right, what about A and D? Let's check that out. Okay. We already have the probability of A from the last try. So now let's do the probability of A given D. Alright, if we're given D, alright, pinto beans. That means we can forget about the rest. Okay, so in this world, what's the probability of A? So A is chicken burrito. Alright, so we have 30 out of 72. Okay, that is not the same as 83 out of 240. Alright, so A and D are not independent. So it's not A and D. Okay. So let's try B and D next. We already did B and C. Let's try B and D. Alright, if B and D are independent, the probability of B given D should equal the probability of B by itself. Alright, let's start with the probability of B. Alright, B is carne asada. Okay, so there's 80 of those out of a total of 240. Alright, that's 1/3. Now let's calculate the probability of B given D. Alright, D is the pinto beans. So we're given pinto beans. That means it's not black beans. It's not no beans. And these totals don't matter. Alright, this is all that matters now. Okay, so what's the probability of B? What's the probability of carne asada? Alright, well that's target over total, 24 out of 72. And that's 1/3. Okay, because these are the same, we know that event B and D are independent. Alright, so that would be the answer to the question. B and D are independent. Let's see, a farmer grows vegetables on 7 acres, fruit on 6 acres, and flowers on 2 acres. Let's write that down. Whoa. Okay, out in his fields, he finds a ladybug. To the nearest tenth of a percent, what is the theoretical probability that the ladybug was not found within the acres of flowers? Okay, not found in the flowers. So, target over total. Okay, the target is not flowers. Okay, so we have so the ones that are not flowers are the veggies and the fruit. That's 13. All right, so there are 13 acres that are not flowers. Out of a total of 15 acres, if you add them all up. So 13 out of 15 non-flower acres.
Once again, in the econ course, all those passengers flying out, maybe you have a medical assist device, like a walker, personal wheelchair, or maybe an item like a stroller or car seat. Please make sure to get checked your next
Okay,
destination.
that's 86.6%. 86.7 if we round up.
All walkers, personal wheelchairs, strollers, and car seats should be checked once you're in the gate area at the local Southwest customer service desk. As always, we thank you for choosing Southwest.
All right, that's why that's the answer. Okay, Belleville High School offers classes on 3 different foreign languages. Let A be the event that a student is in the 11th grade. B is the event that a student is enrolled in French class. Which statement is true about whether A and B are independent? So this question is just like the question that I did 2 questions ago. If you want to check and see if event A and B are independent, then you look at the probability of event A given event B and compare that to the probability of event A by itself. If those are equal, then those events are independent. So here again, you just have to check that. So we would start by calculating the probability of event A. Now, event A is 11th grade. Okay, so there are 138 11th graders out of a total of 552 students. Okay, that's 1/4. Okay, now let's check the probability of A given event B. See if they're the same. Now, event B is French class. So if we're given event B, that means we're given French class. That means not Spanish, not German. And these totals here are now irrelevant. Okay, so in this universe where we're given French class only, what's the probability of event A? Now remember, event A was 11th grade. So here's 11th grade right here. So when we do target over total, the target is 68, but the total in this French universe is 272. So let's reduce this. And that's 1/4. All right, because those are equal, then you know that those events are independent.
Southwest 479
Right.
Philadelphia International on time to Roger.
That's why this was the answer.
E13. All ticket confirmed. Passengers, please make your way down to E13 for
All right.
departures.
That perfectly matches exactly what we just did.
It is open seating on Southwest Airlines. You can sit anywhere.